you do your part in investing all our life and our experience in aerospace in a development of something which has never been done before. And we do our part in considering that there will be an initial phase of the entry into service where there will be an initial penalty. And this is so noble from everybody. Of course, without a projection of profit, no business can work. And there will be profit in the very beginning as well. Otherwise, we will never start to have this type of business. But there is an acceptance of an understanding that what we are doing is not for money only, which is touching from my point.
So we've got the smaller aircraft into service. We've got the regional turboprop powered by fuel cells into service retrofit. What does a clean sheet aircraft look like? And what kind of technologies should we expect to be incorporated on that? And what efficiencies are we gaining from the clean sheet?
Let's start with the university, I suggest.
Okay. I was going to say, I want to hear from Jacqueline, actually. I know that ATI has been doing some really cool work there. I guess I could start. So what would the aircraft look like? The answer is different, right? We developed so let me circle back to something. So hydrogen gets a bad reputation for several reasons, right? But one of the most prominent ones that you end up seeing from the perspective of a lot of the developers of aircraft systems, a lot of the OEMs, is, well, I don't like this high volume, right? The energy density being low relative to the fuel we use today, kerosene. And that's very much true. But I look at that not necessarily as something that is a downside, but actually an upside, because now I've got volume that I can play with. I've got, as a designer of an aircraft, all sorts of worlds of opportunities as far as how the outer mold lines of the aircraft are designed with the integration of these high volume tanks for making the aircraft actually more efficient. It does increase the wetted area, right, that you see. I always tell my students the wetted area is, the amount of surface area that you face if you throw your airplane in a bathtub, right? But what you can also do is that wetted area will increase the parasite drag, but you can also do things like, integrate non-pressurized storage regions into even conventional fuselage designs that are pressurized as quasi-cylindrical pressure vessels, and integrate the system such that the carryover lift along the center line, or the distribution of lift from tip to tip, is more efficient overall. And so one of the key outcomes we saw in Cheetah was that in doing this approach and keeping a basic 737-800 fuselage, but kind of cleverly engineering how we integrate the tanks, we were able to actually create a system that completed the mission with less energy consumption relative to the incumbent aircraft, rather than, more, as most people would suspect, because of the increase in wetted area. I also think that even further developments can be done. A lot of the kind of small to large single aisle aircraft are span limited, right? There's even more that can be done as we get to the larger variants that are, the long haul variants that to get to, Dominic, your point about blended wing configurations. There's other clever strategies associated with how the power system and propulsion is integrated. And again, in a clean sheet context, there's a world of opportunities of developing the power system and the airframe together, right? It might not operate even in the same way, at the same cruise altitude, at the same cruise Mach number. I'm a key advocate for thinking strategically about, if we even just have small decreases in cruise altitudes, we could potentially decrease our cruise Mach number for the same ground speed, because the speed of sound scales inversely with the increase in altitude. I'm kind of getting into my soapbox of let's think about this rather than just assume we know the answer, right? But you perhaps get the point that it really does open up Pandora's box, so to speak, of options that we need to work together as a community to engineer.
Jacqueline, how many of those technologies in the Pandora's box is the ATI currently working on?
Well, we're certainly looking at dry wings, obviously, in terms of, if you haven't got kerosene in the wings, how that might affect the high aspect ratio sort of preference to improve aerodynamics. There could be a lot more room for systems and other items to adapt things like the high lift devices on the wings with that sort of design. We're looking at a lot of materials and the manufacturability as a result of that as well. So a lot of that is included in the roadmaps. I suppose we're also trying to look at how we can bring those technologies into an aircraft that can be exploited quite quickly, you know, within the sort of 2050 target. And so if we were to go completely clean sheet, really radical, it's fantastic. However, we also need a little bit of realism, perhaps in some time, how we can bring those steps, you know, to really exploit them into an aircraft. So I tend to favour the fact that we still may develop another more conventional looking aircraft first with hydrogen, growing, you know, on from the sort of likes of what ZeroAvia are starting on at the moment. And taking really things like high aspect ratio into wings into account, and other aerodynamic improvements, maybe laminar flow, things like this. So it's going to be small steps, but obviously it does open up that design space in precisely the way that Phil is explained. It can be exciting times.
Do you agree with all of that, Gabriele?
I think I want to get things done in my life, and if I had the chance to design a new aircraft and install hydrogen electric engine, I would think about the tanks first of all. I'm not scared about propulsion system. With the distributed propulsion, we can deal with size and positioning, and I'm not scared about the behavior of them, the vibration, the installation, the integration. I'm not scared at all. Also, the length of the cable is something that can be solved, and the positioning of the engine far away from the wings. And the fuel cell, you know, we were speaking about education. So once we understand how the fuel cell works and where is the hydrogen moved and where is this position, is another box that can be installed on the aircraft. What I'd like to optimize is the position of the tanks. I can't believe that the tanks are just hanging outside, being big missiles on the wings, or being carried in strange position of the aircraft. We will need to have a design where the passengers are staying in the same position where they are today, and there is a distribution of baggage and tanks probably in the bottom side of the aircraft, which is allowing the minimum range we can access. And then the potential of distributed propulsion, of course, will allow to have much lighter components on the wings, and then you can really open design space on that side and improve the efficiency enormously.
Okay. Possible last question from me then is, do we get, or can we get to a long haul hydrogen powered aircraft without going the combustion? Can we do it with fuel cells?
I will start, of course.
Yeah.
I will start, and of course the technology for the what we call 2 megawatt engine is there. There is a scalability on that technology which is possible. We have worked with a different OEM, the Havilland, Mitsubishi Heavy Jet Industries, defining the potentiality to extend this type of technology to bigger aircraft. And there is a non-blocking point statement at the end of this feasibility study from every single partner, which is telling, even considering a small amount of development of the technology that we have already available today is multi-RL, the hydrogen electric engine is capable of feeding this type of aircrafts. The reality after the feasibility study is the integration of the engine into aircraft, like I was telling before. It's not about retrofit anymore. It's not about finding a space for the tanks. It's designing the space for the tanks and designing the most efficient configuration for that part. Same discussion. We need to get there and to have demonstration of simple available technology working, infrastructure growing together with the engine and aircraft, and then making the next step.
I mean, just to add to that, so at the moment, that's one of the questions that my team is studying, exactly where could be a crossover point between fuel cell sort of hydrogen technology and hydrogen combustion engine sort of technology. So I think the jury's out a little bit for me on that question. We'll have a long way to go, but it's a really interesting point to understand, to know where to sort of try to target our focus for the future.
And I certainly have an opinion on the matter. So I am an evangelist for hydrogen gas turbine engine fuel cell hybrids. We've done some preliminary work in the area, and it is an approach to the power system that is really, really intriguing. There's a lot of stuff that you can do with, you know, such a hybrid system and how then it affects the principal sizing characteristics of the aircraft. And so that's really something that I'm very excited about, and it scales right to these larger platforms. You know, there are ways that you can do hybridization that is beyond just what you might commonly think of for, you know, adding mechanical spool power through an electric motor that is driven by a fuel cell. Fuel cells have their own air handling system. What if you mix the air handling systems of the gas turbine engine, and you can resolve some of the issues or challenges of how they lapse with altitude, right? So there's a world of options, for instance, that these hybrid variants would permit, and something that we're concertedly studying at the moment. So that's my answer. Is I think that the answer is actually yes, rather than one or.
Okay.
Tom, I think we may have lost Tom there. He's just about to wrap up, I think.
Sorry, I was waiting for you to jump in fact.
Great. No, well, I mean, I'm sure you. Thank you, Dom, for moderating brilliantly, even from without video. And thanks for Jackie, Phil, and Gabriele. Really interesting session, and actually great. The last question is a really fascinating one, which we'll explore more tomorrow. We have a session specifically looking at, can we scale the technology for narrow-body aircraft, and what does that mean for the aircraft, and what would it mean for hydrogen infrastructure at airports? So we look forward to that one tomorrow. But we've got one more session for everyone today, and I think on panel 3 we talked a little bit about Christmas wishes. Imogen asked the panelists what would be their Christmas wishes, and one of those certainly was more money. Right, we need to progress